I hope everyone online here can hear me. All right. So this is basically identification of missing hierarchical relationships in the vaccine ontology using a methodology that we call acquired term pairs. So this is joint work with Rashmi Abhay-Singha, Dr. Oliver, Dr. Sweetow, and Dr. Likong Sweet. So coming into this ICBO conference and as a non-ontology person, it's both equally or inspiring and a little bit terrifying. But one of in the workshops, something that I really resounded with was during Nico's workshop, where he mentioned that open ontologies, the three main principles of being no ownership, upstream fixing, and collaboration. So here we go. Right. So for the outline of my talk, I want to give a brief introduction of the vaccine ontology, although I think that is not really necessary since we have the vaccine guru himself here. Go a little bit into why quality assurance for the vaccine ontology is required, what related work has already been done in quality assurance for ontologies, and dive a little bit into the methods of how we represented our concepts, how we constructed our acquired term pairs, and how we leverage acquired term pairs to identify potential missing ESA relations. Then we'll look into the results, how we evaluated them, and look into the future directions. Right, so the vaccine ontology. The vaccine ontology is, like it says, is in the domain of vaccine and vaccination. And it's a community-based ontology developed with the support of collaborators from the vaccine and biontology communities. It has core terms ranging from the vaccine to the pathogen to the vaccine administration and the immune response. And it reuses terms from KEBI Foundation Model of Anatomy and IDEO. And it contains over 6,800 concepts. I think the latest one is much closer to 6,900. So why quality assurance is required for the vaccine ontology? So in this post-pandemic world, if we can still call it post-pandemic, there is a lot of rapidly evolving biomedical knowledge, of which the vaccine ontology needs to be updated with. And being with the added burden of being a community-based ontology, it may suffer from both incomplete knowledge and inconsistent modeling. So one of the other main reasons that why it's necessary is that the vaccine ontology has many downstream applications, including 15 ontologies that it feeds to. The QA is essential because, like we mentioned earlier in terms of upstream fixing, is that we want to avoid these errors propagating from the source. And when it comes to manual review, it takes a lot of time and we need domain experts for that. So the best case scenario is to try to find at least a semi-automated method for quality assurance. So I have actually jumped the gun here and kind of shown what we have done in terms of using acquired term pairs. And this is actually one of the validated missing user relationships that we have identified. So why can't we do something similar in for example, like Protege, is because it does have inbuilt reasoning support, but what it really comes down to is errors of omission is basically, we are not going to catch that. We're not going to catch logical inconsistencies that come from errors of omission if it's not there. So this is actually from the Ontology Foundry dashboard, that the brilliant dashboard that I was introduced a few days ago. So like one of the example ontologies that the VO feeds to is like we saw was CIDO. Related work that has been done using like in terms of quality assurance for ontologies is Abstraction Network, where we try to abstract in a higher level the ontology and try to identify locations of where erroneous concepts are. And another one is actually done for the gene ontology using lattice subgraphs, which is actually where we try to identify, because there is an ideal lattice structure that we expect ontologies to have, and whenever the lattice properties are violated, we can identify those places as requiring changes. So looking into the methods of what we did here was, I'll briefly explain like how concepts were represented, how we used already to extract ancestors and leverage that to find out, to create basically a list of linked and unlinked concept pairs, and then how we generated our acquired term pair, ATP, for each of these concept pairs, both linked and unlinked, which is basically how we represent a concept pair as its lexical representation of its lexical features, and how we leverage that acquired term pair to identify potential missing either relations. We did have to do certain post-processing due to certain conditions of the vaccine ontology, which I'll go into in later slides. So the core concept of concept representation is I was able to parse the vaccine ontology OWL file using OWL-ready2 to obtain the name and simply the name and the ancestor for each of these concepts. In terms of how, for example, there's actually a small typo here, so you can, it's concept 1 and concept 2, where FC1 should be FC2. A concept is represented, we do certain normalizations, which is basically, we convert the entire name into lowercase so that we don't take, it's case insensitive. And then we do tokenization, where we break down each concept into its own words and we remove duplicate words. And we can represent each concept as its lexical characters. How we extract linked concept pairs is fairly simple in terms of, since we already have the ancestral data from passed from OWL-ready2, we basically look into two requirements to classify two concepts as a linked concept pair, which is it essentially one has to be an ancestor of the other. We don't really assume to see each other because that would create a cyclic dependency. And each of these have to have at least a single common lexical feature, in other words, a single word. So as you can see in this example, viral vaccine and infectious bursal disease virus vaccine has a common word, vaccine. So we would take this as a linked concept pair. Unlinked concept pairs was a little bit less straightforward, where what we did was essentially try to remove, it needs to fulfill a little bit more additional requirements in addition to like, as opposed to the linked pairs, which is the concepts should not be equal to each other, because we found certain concepts like duplicate concepts in the vaccine ontology. So that was one reason, and they should not be ancestors of each other. So we don't want to try to imply that a reverse relation is already there when it has a directional relationship. And thirdly, it needs, again, like in linked, it needs to have a single common feature, and it needs to belong to the same ontology. Like I mentioned earlier, the vaccine ontology uses multiple ontologies like TEBI and IDO. So we don't want to try to imply that there are certain missing either relationships between these ontologies. And there was an additional requirement, which was that there are 19 sub-hierarchies under the BFO concept material entity, which basically encompasses most of the vaccine ontology, around 82%. That is from anatomical entity all the way to vaccine components. So why we do that is we want to try and infer unlinked or like missing relations that are relevant but not all out of the way. So generation of an acquired term pair is basically the difference of the words bit of each concept representation. So here we see infectious bursal disease virus vaccine and viral vaccine. So it's basically concept 1 minus concept 2 and concept 2 minus concept 1. So how do we leverage this to try and predict or try and showcase a missing is a relationship? Is that we understand that if from an ancestor to a descendant, we assume that certain features are passed down. So if the same acquired term pair is present for both already linked concept pair and an unlinked concept pair that we have already identified, we suggest that this may be a potential missing is a relationship. So as you can see here, the acquired term pair of infectious virus, sorry, the resolution is a little bit too small for me to read it out, but essentially both the linked concept pair and the unlinked concept pair share the same acquired term pair, and we suggest that this may be a missing is a relationship. We did have to do certain post-processing of our results. Like I mentioned earlier, there are some duplicate concepts in the vaccine ontology. As you can see here on your left and on your right, the F fusion protein that it's trying to say that there is a missing is a relationship actually was under, like it's trying to assume that it's from measles virus protein to a fusion protein, whereas the fusion protein where on your upper right side is actually nested under Nymphia virus. So this is basically, since they are identical concepts, we filtered out any inconsistency which shared the same concept name. These, because at the end of the day, what we were trying to identify was missing ISA relationships, and we wanted to focus purely on that sort of errors. The results. So overall, out of this was for the vaccine ontology version 1.192, I believe it's 208. That is the latest right now. Out of those 6,800 concepts, we found we generated around 62,000 linked concept pairs and a little over 17 million unlinked concept pairs. And out of all of these, we were able to identify 232 potentially ISA relations, missing ISA relations. In terms of how we wanted to evaluate it, since at the end of the day, manual evaluation is a little bit time consuming, we went down with 95% confidence interval and 10% margin of error, and it came down to 69. So we rounded it up to 70 potential missing ISA relations. And what we did get was the validation was that out of the 70, we found that 65 were actually proper valid missing ISA relations. What we did do here was narrow down our unique ATPs so that they are not overrepresented. Basically, out of the 232 missing relations, there may have been one specific ATP or acquired term pair that suggested multiple missing relations, but we narrowed it down to just one so that we have unique ATPs so that it's not overrepresented. So we got a good overall precision of a little over 92%. So these are some examples of valid missing ISA relations that we found, which, for example, human papillomavirus protein ISA, human protein, COVID-19 recombinant vector vaccine ISA, recombinant vector vaccine. So as you can see, all of these, all of the relations that we are predicting are within the same ontology. So I have basically given all of the VO terms here, but we did find certain NCBI taxon terms as well that were that was actually a valid ISA relation. Looking into the 5 false positives, if we look at the first example, smallpox vaccine and smallpox virus vaccine, we got it confirmed that these two are actually synonymous terms that need to be merged into one. So essentially, it is an error, but what we do count here is missing either relation, so that we basically we counted it as a false positive. The second example is a gram-negative bacteria and dog. So that is essentially not an either relation. And the third example, the two corynebacteriums are actually siblings of the same parent. So that definitely is an error on our end. For the fourth and fifth, we had a little bit of uncertainty in terms of the domain expert. What he suggested was that in the fourth example, it's uncertain if the vaccine, I'm not going to read out the entire one, the example, the descendant is always an injection. So it was a little bit uncertain, whereas in the last example of toxoid vaccine and toxoid, it's usually toxoid, which is a component of the vaccine. So that was it. Again, it was a little bit of a gray area where we couldn't get it validated. So we clumped it under false positives. In terms of the conclusions and future directions, what we essentially did was apply the most simple, like the whole goal going into this was try to find the most simple implementation of ontology quality assurance. We didn't leverage anything else in already other than just extracting the name and its ancestors. But it's a simple, and we have validated method of identifying missing either relationships. And what we do have in terms of limitation is that it always has to be concept pairs with common words. So there definitely may be concepts that do not share words, and that may result in an incorrect missing either relation. So in that sense, the net could actually be a little bit wider. And if you see that what we've actually performed is very simple in terms of normalization, it's just lowercase tokenization, removing the duplicates. But there can be additional normalization strategies that we can do in terms of lemmatization, looking into synonyms, a little bit more into stop words. And we don't use any of the other lexical metadata. So probably these are going to be what we are going to focus a little bit into the future. I think these are my acknowledgements, and thanks, and I will try to answer any of your questions.
Go back. So how many missing is in total?
We found 232.
Okay. So for that sample, 70 sample you took out, how will you tell us within these 232 there are false positive that you need people to check? Because I can find a domain expert. Like for example, I have this FDA requirement, we have to get 100% accuracy in order to use this. How will you give me the list of false positives?
I don't think I'll be able to provide the list of false positives, but what I actually can provide is a list of the 232 potential relations. So the good thing about this is all the domain expert needs to do is to validate if there is an either relationship here.
But you didn't do it. Why? It's only 272. Right?
Yeah, it was a constraint in terms of finding the people to, basically it was Dr. Oliver who did our domain expert. So we just use a sample of our entirety, but ideally, yes, if we could have got all 232 validated, that would have been much better, and hopefully we can get a little bit more validated and help improve the vaccine ontology.
Okay. So besides, like, for example, if you have a large scale of this either relationship that you predict, maybe you predict like 20,000 either relationship. I don't think a human, it will take a long time for human. Do you have any solution to narrow down the things that human needs to validate?
Yes, in terms of that, there are certain things that we might be able to leverage. So what we are able to find out are what what are the corresponding linked pairs for each of the unlinked pairs. So what we can assume is that if there is a relationship that we are suggesting and it's backed by multiple linked concept pairs, we can probably use that as a confidence score in terms of like how feasible the prediction is. So that's one of the methods, I guess.
Thank you. Do you have a question?
One question I have is that did you take a look at when each of the terms that are missing is a pair were added to field? So is it the result of some of the terms were added earlier on during development in like version 0.63, then later on a later edition in like version 152? And so how much of a time gap was there between these relationships?
We didn't really look into anything between the versions. What we did was use the most current version at that time, which was 192. But what I did do was run this on the latest one, which was, when I checked, it was 198. Oh, yeah, the latest version, but I was still able to find the same 65 that at least that we got validated. Those missing relationships are indeed still missing. So
Yeah, so just give you a context. I was working with the Odyssey group. They want to build out all the human vaccines and also the human vaccine related some features, like for example, what pathogen are there linked to a certain human FDA licensed vaccines. And I look into vaccine ontology, and I realized I actually couldn't do a good job because there's a lot of things missing in the vaccine ontology. So I think after this, there are other things like how you will identify the pathogens that is related to this vaccine will be next step. Besides you, I give you a lot of work. Besides you, yeah, make sure that is a relationship is not missing. So then it will be really useful.